Hey everyone, Wazoo here with another episode of Wazoo Web Bytes. And in today's little adventure, we're going to be looking at adding Docker container support to our to-do application that we built in our previous episode of our newly created Spring Boot 3 application. I'll put some links in the description down below, and I'll link to the previous video above, so it might hover above somewhere. Wherever YouTube puts it, I'll drop it there. So if you haven't come across Docker yet, Docker is a way to run and containerize applications that you are building together. So web applications, the most common use case is for web applications. And by containerizing, you can extend the lifetime of your application, make it easier to support, as well as be able to easily deploy and run it on any cloud environment, such as Kubernetes. What containerization means is that you can create a sort of virtual space where your application is being built and executed, which will not interfere with the host space. So, for example, if you're working on a Rails 7 application, and in your environment, you've got a bunch of different applications that you're supporting and working on, some of them with different versions of Ruby on Rails, or even Java Spring Boot. There's a good example there. We've just recently built this application with Spring Boot 3, but you might be using in some other folders that you're supporting an application written with Spring Boot 2 or even 1. So the idea is that you can create an environment where you can separate out all of these areas into different containers to execute them independently of each other. Long-winded answer, but basically it's a virtual environment, virtual machine 2.0, if you recall using virtual machines back in the 90s for developing. These days, it's usually a lot easier to set them up in Docker and go from there. All right. So I'm using Visual Studio Code for this little adventure. As you can see, it's up in front of us. I'm in our current application, and we've got nothing on master. Let's do a quick git status. And nothing there. Okay, great. So what we're going to start off with is just making sure that you've installed the Docker client. Now, there's different instructions depending on the operating system you're using. So I've installed the Docker desktop client for Windows, and I'm running this on through a WSL2 command shell. So long story short, if you type in Docker version, then this is the version of Docker that I've got running. You'll do the same on your end, and if you've installed the desktop client correctly, then you should see a version number coming back. It's very easy to install. It's just going to docker.io and then just downloading the client for your operating system, installing it, following the installation instructions, and installing it there. Okay, so first of all, we've got a few commands that we can list. They won't really make sense until we build something though. So again, we've got Docker set up. So the first move that we're going to create is we are going to generate the actual executable jar file of our to-do application. And so if it's been a while since you've done that, we can package it up with the installed mvnw. So let's just type in mvnw install. And that will go ahead and it'll create our Spring Boot, the current state of our Spring Boot application, and build it into the /target destination folder. Okay, so we've got it. We've got a build success. And if we see in the target folder, we've got our Spring Boot 3 to-do application /jar right there. Maybe the green coloring doesn't show up too well. Anyway, so what we can do is we can execute it with java-jar, and then the pathway to it is we can just do star.jar because it's the only jar file there. And it should start up. and be available as usual on port 8080. Okay, so here we go. Tomcat started on port 8080. Perfect. So let's Control C out of that. We'll shut it down. And then let's go ahead and let's create what's called the Dockerfile. So this is a sort of a configuration / build file, that a special name that Docker uses. So for every project that uses Docker in, you're going to have a capital D Docker file. So let's go ahead and create that. And I'll quickly open it up here and then move this back just so we have all the room we can for this. Hopefully this text is big enough. Sometimes I've had issues. Let's just make that a hair bigger. Oh my, okay. Well, hopefully this is not too ridiculously big. Okay, so the first things first, what we are going to do is we are going to create a Docker file to run that jar file that we just built. So at the very top, we want to type in from, and then we want to be using openjdk 17-jdk-alpine. So I'll put all the links to my Visual Studio Code extensions in the description down below. You'll see that it's filling things in as we're typing. So openjdk alpine, which is a special Docker image that's hosted on the sort of Docker Central site. So similar to the NPM registry or Maven repository, the Docker has its own sort of container repository that you can pull images from. So we're pulling down the openjdk 17 JDK Alpine image. Let's create a variable called arg jar file, and we're going to make it equal to target / star.jar. Star.jar. And then what we're going to do is we're going to add jar file. We're going to add it to our container as webserver.jar. And then we're going to be exposing port 8080 because that is the port that our Spring Boot server is running on. So we're exposing port 8080, and then we're defining our entry point as Java jar and then /webserver.jar. Okay, so just to recap what we're doing, we're making use of the openjdk 17-jdk-alpine image from Docker. We're creating a variable name called jar file, which is equivalent to the location of our generated jar file, so target / star.jar. Then we're adding this jar file and we're adding it to the container, and we're renaming it as web-server.jar. Then we're exposing port 8080 from the container, Docker container, and then finally declaring a entry point of java-jar /webserver.jar. Okay, so let's save that and go back to our terminal window, using this file to create what's called a Docker image. So let's use Docker build, and then we need to pass a -t, which creates a tag of wazoo /webserver :v1. So the :v1 is the version number that we want to give to this image. And then we use the dot notation to basically we're defining where the Docker file is, which is the current folder. So Docker will do its thing. It'll pull down a whole bunch of things and create a new image for us. Okay, so Docker has built this image for us, and to see the list of images that you've got on your system that Docker recognizes, you can just use docker /image ls. And there we go. We've got our wazoo /webserver tagged as v1 with an image ID created about a minute ago. And you can also use a docker container ls, and this will list the existing containers that are on the system. So right now we've got none. So what we want to do is we want to run this image as a container. So we type in docker run -p for port, and what we want to do is we want to map or expose, whatever kind of wording you want to use. We want to map port 3000 to the outside world to bind to port 8080 on the image, which is where our Spring Boot server is listening on. And then we space / web server v1. So we want to use the v1 image. Okay, so Docker will start up. And it's still listening on port 8080 as you would expect. Now let's go to localhost 8080. And you'll see that there's nothing running there. It can't be reached. Because what we did do is, remember how we've exposed this application, we've mapped it to port 3000. So now we see the application come up on port 3000. Let's just blow it up a little bit. Okay, so that looks all fine and dandy. So back in Visual Studio Code, let's go ahead and hit Control-C. This will stop this container running. If we open Visual Studio Code, I've got the Docker extension loaded up there, and you can see that we've got our container that we've just created, and we've got a list of images, which right now we've only got the one. We've got v1, which exposes port 8080. So now let's create another image. So wish there was a fast way to do that. Okay, so now let's say that we want to create another image for openjdk 19. So let's update our Dockerfile to use 19 instead of 17 for the image. Let's go ahead and save that. And the rest we can leave the same. And we're going to be using let's rerun our Docker build. I won't even scroll upwards, it'll probably take too long. Let's rerun our Docker build -t, and we'll call this wazoo web server v2 dot. So v1 is using openjdk 17, and v2 will be using openjdk 19. And this is just to show you the power of creating different images depending on what kind of environment you want to run and set up. Okay, so that's finished. So what we can do this time is, again, use docker run, and we're going to expose port. Let's map this to 3001, and we'll map it to port 8080 of wazoo web server v2. Okay, so it's now running, and it should be listening on port 8080, which it is. We see that there. And let's go back to our browser. Oh, wait, let's go back here in the first log message. It should be that we are using Java 19. Hooray. I forgot to point that out. So in the v1 image, you'll see a Java 17 sort of log message here. So here we're using Java 19 as we've defined in our from declaration there. And let's go back to our browser. And again, refresh on port 3000. Nothing should be there because we are on port 3001 for this container. Perfect. Okay, so let's go ahead and stop that. So we've got two. If we open the Visual Studio Code extension window back up, we've got our v1 and v2 images and our two different containers that we've created using the two different tags. So far, so good. Now, what we want to do is kind of take this to the next step. So part of the power of Docker is being able to do what's called composing. And this is where we can create a way of containerizing many different elements of your web application and environment. So let's say you've not only got this Spring Boot server running, but then you've got another container which has your database, which could be like Postgres, MySQL, and then you've got another container for something else that you might need to run in conjunction with your application. So maybe some kind of like third party, you've got to run some third party services, messaging services, like maybe Rabbit or something like that. So you can separate everything out on different Docker containers. So the Dockerfile defines the individual sort of like how to how to work with the current application. So what we can create instead, or not instead, what we can create additionally is a file called docker-compose. And this will allow us to put together different Docker containers into a single, basically when you start it up, it will then kick off all of the different containers that you want as part of your executing environment. So let's now create a new file called docker-compose, docker-compose.yml, still in the root folder. And let's go ahead and open it up. Let's see, can I just double click on that? Nope. Okay. So this is where we basically define what image we want to use and what port. Basically, it's a configuration file which replaces the docker run command by itself. Okay, so at the top of the docker compose file, let's define a version of 3. And then let's create a services section. And the first service we'll just give a name of web. So this can be anything. So this can be, we can call this server. We can call it anything, but it's used when you have different services put together in a single Docker Compose file. So right now we only have the one, so we can call it whatever we want. And we need to, we're making use of the image wazoo/web server v1. So our openjdk 17 image. We need to define a build, and we'll just leave it as dot. And the ports we're going to be using are, again, Visual Studio Code will help you out with some IntelliSense on what you can use. So the host port is what we want to expose to the outside. So again, it's the 3000, and then we want to map it to the container port of 8080, or bind it to the container port of 8080. So let's go ahead and save that. And then back in the command line, all we need to do is a docker compose space up. So it's running everything that's defined in this docker compose. So you'll notice that with the logging, it separates things out based on the name that we've given it in the docker compose file. So our application is up and running on port 8080, and it is listening on port 3000. Okay, and so let's Control-C out of that. Now what we can do is we can run it as with the /d command, which runs it as a daemon or as service. So if we type in docker compose up and then -d, it will then run docker compose up as a daemon. So it's now running, and we can see in the Docker tab that it's running, exposing port 3000 mapped to port 8080 on the container. So what we can do, we can also shut it down from the command line with docker compose down. And so it'll stop the currently running container, or the currently running environment. Okay, so we've got another command called docker-ps, which will list anything that's running. And right now we don't have anything running, so let's just demonstrate how it's working again. So docker compose up /d and -d, and this will run it as a daemon. And then if we run docker-ps, it will show us what's running, which is our v1 image with the command java-jar /web server .jar, and then it'll give us a status where it's mapped from port 3000 is mapped to port 8080 in the container. Okay, so now what we want to do, let's go ahead and shut that down. So docker compose down. So now what we want to do is we want to create a version 3. Let's create a version 3 because we've already got a version 2 tag. Let's create a version 3 image of our application where we're also building our application. So if we're making changes to the source file and then we're running it with Docker, you'll remember that we're not rebuilding anything. We're just running what's in the image, which is the jar file that we built at the beginning of this video. So let's go back into the Dockerfile, and at the top here we'll add another from openjdk 17-jdk-alpine. Let's make it 17 for both. And we're naming this as build. So this is sort of the build phase of our Docker process. So let's create a work directory, and we're just going to call it workspace app. And then what we want to do is we want to copy mvnw into, basically it copies it into the /workspace/app virtual area of the container. Copy the mvn folder. Also name it, like keeping the same name, and we want to copy the pom.xml file. We want to keep that the same name. And then we want to copy the source folder into the source destination. Basically all we're doing, so again, if it looks a little bit confusing, we're creating a workdir. So basically we're setting the working folder to be /workspace/app. And then we're copying, this is the first parameter of the copy command is from our existing project right here. And we're copying it over into our current workspace, our current working directory, which is /workspace/app. So then we're copying the .mvn folder and also keeping it as .mvn. We are copying the pom.xml file and preserving the pom.xml name. And then finally, we're copying the source folder structure over into the source folder structure in this /workspace/app area. Okay, and then what we want to do is we want to run mvnw install, which rebuilds the jar file as we did when we first started things up. And then we continue down into this section, which we need to make a little change. For our argument, instead of our jar file being in target/star.jar, we need to update this path to be /workspace/app target.jar. And then what we want to do is we want to copy, instead of adding here, these Visual Studio highlights. So we want to copy, and we want to declare the from to be the build phase, like the build stage of our jar file into our as webserver.jar, similar to like what we did before. And we're still exposing port 8080, and we're still keeping the entry point the same. Okay, so we've got all that done. So what we want to do is we want to go back again, and let's create this as a version 3 image. So again, we use docker build -t and then web server :v3 and then dot. So let's put everything together. Docker image ls. We can see that we've got 3 images now. And then in our docker-compose file, we can update that to use version 3. So we've got an image now where we've got a build step where we're rebuilding our jar file. So we've made a change to our index. Okay, so to show changes, so let's say you've got your, let's go ahead. Okay, so we've got our Docker Compose file, now referencing the v3 tag of our wazoo/web server image. So this is that image that we've just defined, where we run mvn install. We generate the new jar file based on the current status, the current state of the code base. So now let's demonstrate how to rebuild it when you want to pick up new changes to the code. So for example, if we open the index.html template, and let's just update this to say Todo Application with Docker. Something, anything, it could be any kind of text. So if we run Docker Compose as is, so Docker Compose up, let's rebuild. So Docker build, okay, Docker build version 3. Let's go ahead and you'll see the steps here that we are copying the required files over. We're rerunning the build, the jar build. And this will build and run the current state of the code base. Is what will be in this image. So we've got our version 3 tag. Now let's go ahead and we can run it with Docker Compose up. Let's double check the Docker Compose file. Yeah, it's referencing our v3 tag. So let's use Docker Compose up and start up the web service. Okay, and you'll see here, let's refresh port 3000. You'll see our application up and running. Now, what happens when we make source code changes? We've now built an image containing the current state of the source code. So if we update our, let's just go into the index.html template and let's update the title to be like, I don't know, Spring Boot 3.0 Todo Application with Docker. Let's just, or you know what? Let's just make a little like sub headline. Now supporting Docker. So if we run this as is with the Docker Compose up, then this is just showing that none of our source code changes are being picked up because we are referencing the image that's currently built and static. Okay, so let's Control-C out of this. And what we need to do, remember how we, in our Docker Compose section, how we've given our service a name of web. So what we need to do is force a rebuild of this web service. So using Docker Compose, so Docker Compose, and then up, -- build, and then our service name. So in this case, it's web. So if you remember, if you gave this one a different image, a different service name, so let's say you called it server, then instead of build web, you would be using build server. So I'm going to keep it web just to be consistent. And let's go ahead and redo that. So what it's going to do is, it's again, you'll notice that it's recopying everything, rerunning the build stage of this Dockerfile, which is our build process. Okay, so Docker run has started up and it has restarted things up. And let's go back to our browser and let's refresh it. And we should see now supporting Docker. Nice. So now we've got a Docker support built into our Todo application. We've gone through how to create your own Docker configuration file as well as your composing configuration file. And then within those, define the services and steps that you need to be useful with Docker. Yeah, this is, definitely see this as a introduction to using Docker. You could really dive deep down into making use of this cool technology, which really makes it a lot easier to execute. Well, not only execute, but work on your local system with different environments, different frameworks. Maybe you've got one for different versions of jQuery if you're needing to fix something with a specific version of jQuery. and etc. Like you can really isolate different sections of your application that you want to work on depending on what your goal is. So I hope you enjoyed this video. Please give it a like and subscribe to the channel if you want to see more like this. Leave any comment down below that if this didn't work for you, or if you had a great time with it. So hopefully you're having a great day wherever you are, and we'll see you in the next video. Thanks everyone. Peace.